Hello everyone. Today we are going to solve question number 167 to sum 2. Okay. So in this question you're given one index array of integer numbers. Okay. That is already sorted in non-decreasing order. And then you have to find two numbers whose sum adds up to target. Okay. So basically in this question what you have to do is you have to return the indices of these two numbers which on the basis of one indexed array. Okay. And the two more statements given over here as there is exactly one solution in each test case. Okay, exactly one solution, and you cannot use the same element twice. Plus you have to solve this question using of one space complexity. Okay. So in this question, there could be multiple approaches to solve this question. Okay. So basically, we are going to discuss these three approaches here: the brute force, the binary search, and the two pointer. Okay. So let's discuss them. So the first one is brute force. Same constraints. There is sorted. One base indexing is required, and we have to return the pair of indices. Okay. What we can do in this question is we can traverse the array in nested fashion, and then we can check the condition being that the sum of the two numbers like 2 plus 5 is equal to target. Okay. And then recording according to the one return according to the one based indexing. Okay. So you can see visualization here that we had the array. Okay. So the first element is picked by the first traversal, the second element is picked by the nested one, and then we are going to check if 2 plus 5 equals 9, then we are going to uh, like check. Okay, so you can see it's no, then we're going to iterate again inside the nested one, and we reach 7, then we got 2 plus 7 is equal to 9. Yes, then we are going to return on the base of one based indexing. Okay, so it's very simple, just you have to use nested fashion and first pick one element and then iterate over the rest of the array to find its complement. Okay, so let's code this one. So what you have to do is you have to iterate using nested fashion. So int I equals 0, I less than n, I plus plus, for int j equals I plus 1, j less than n, j plus plus. You can see I'm using I plus 1 over here because we cannot use the same element twice. Okay. Uh, Now what you have to do is you have to check the condition. So if numbers of I plus numbers of j equals target, then what you have to do is you can directly return it. Okay, then you can return I plus 1 comma j plus 1. You can directly return in this format. Else, if we didn't find any solution, although the question guarantees that there's exactly one solution, but still for fallbacks, what you have to do is return an empty braces. Okay, so this way we have coded the brute force. Let's run this, and obviously this was a utility to use in all these three approaches. Okay, so it's accepted. Let's submit this. So we got a time limit exceed. Okay, so basically 23 out of 24 only the last test case. So you can see that this question has of n square time complexity because we are using two nested loops. So we have to optimize this question, optimize this solution. Okay, so what you're going to do is we're going to use this binary search for complement searching. Okay, so basically in the last part what we are doing here, we were finding this second element using another loop. So O of n with O of n, we got O of n square. But this time we are going to search the second element using binary search. Okay, this is the simple difference between brute force and binary search one. Okay, so what you have to do is, as you can see here, you're going to traverse the array and then you're going to calculate the complement. Okay, of the current element. Then what you have to do is you have to search this element using binary search. Okay, if you found uh, using the binary search, then you can directly return the answer, else you have to return the empty, or you're going to iterate forward to solve for another question. Okay, so you can see here that we had this array and we picked the first element. The complement for 2 will be 7. Why? Because target is 9. 9 minus 2 is equal to 7. So if we found 7 in the rest of the array, we are going to get an answer. Okay, so here you can see we are going to implement binary search in this restore leftover array. Okay, so you need a left pointer, a right pointer, and then we are going to like small we are going to smallen the search space. Okay, so let's code this one. Okay, so what you have to do is you have to first iterate. So first int I equals 0, I else then n, I plus plus. Next step is to calculate the complement. So int complement is equal to target minus numbers of I. Okay, now what you have to do is you have to use binary search to find the complement. Okay, so for binary search you need two variables that we discussed, L and R. Okay, so int L is equal to 0. Oh, sorry, L is equal to I plus 1. Why I plus 1? Because we cannot repeat the same element, so we have to search in the leftover array. Okay, int R equal to n minus 1. Okay, now what you have to do is you have to use binary search. So how you can write binary search is L less than equal to R. So, okay, this condition to smallen this search space. Then if numbers of mid, okay, so you have to calculate a mid. Okay, int mid is equal to L plus R divided by 2. Okay, if numbers of mid equals complement. Okay, then you have to directly return for answer. Okay, so return I plus 1. So I plus 1 for that one based indexing, and mid plus 1 because we found the complement at mid, so mid plus 1 will return on the basis of one base indexing. Okay, else if complement is greater than numbers of mid. Okay, if complement is greater, that means your current left is way too back. Okay, so we have to move left forward. So what you can do is uh, left is equal to mid plus 1. Okay, else the other case for this one will be complement is less than numbers of mid. In that case you have to do R is equal to mid minus 1. Okay, this is standard for binary search. Okay, and for the fallback, if after the whole loop we didn't get an answer, although it's guaranteed that we'll get an answer, then you have to return empty places. Okay, so I think this should run. Okay, let's run this. Okay, it's accepted. Let's submit this. So basically we have solved this using of n log n time complexity. So we have utilized binary search inside a loop to find its complement. Okay, so this was also a solution to this question. Now the third and the most optimal solution to this question will be two-pointer approach. So let's discuss what we have to do for two-pointer approach. Okay, so as you can see in the two-pointer approach, what you have to do is you have to initialize two index pointers. Okay, one at the beginning, other at the end. Okay, if we directly got the answer, then we are going to return it. Okay, return the indices. Okay, obviously we're going to return the indices. Else there's a greater one case, there's a smaller one case. it needs to be handled. If the sum is greater, then we are going to move R. Okay. And if the sum is lower, then we are going to move L. Okay. So you can see here there's a visual for you that as we initialize two index pointer here, one is L, other is R. Okay. Current sum is 2 plus 11. 2 plus 11 is called 13. So it's greater than 9. What you have to do is you have to move R. Greater case, move R backwards. Why? Because since the array is sorted, moving R uh, towards the left side is going to uh, s- then we are going to find a smaller element. Okay, so by the sum of smaller element we might be able to find the target sum. Okay, so as we moved it, we found 9, and hence we return the one based indexing. Okay, although our examples were pretty easy to discuss, like we just have to do one step and we found the answer. But there could be more tough test cases for these questions. Okay, so let's say that you had the target equal to 12. Okay, if the target was 12, then what we would have done is, first thing that we saw that the sum was 13, so 13 was greater than 12. We, would- we would have reached the same state. Okay, but now the sum would be 9. Then what we were going to do is we are going to move left. Okay, so left will reach here, then 5 plus 7 is equal to 12, and then we are going to get the target as 12. Okay, so let's code this one. This is the most optimal approach to solve this question. Okay, so what you're going to do is we are going to, firstly we need two pointers to point. Okay, so int left is equal to 0, int left equal to 0, int r equal to n minus 1. Okay, now what you have to do is you have to uh, iterate over it. Okay, so what you have to do is while l is less than equal to r, same as binary search. Okay, if if numbers of l plus numbers of r equals target. Okay, so I cannot do equal to because obviously you cannot point to same element twice. Okay, so okay, while l is less than r, numbers of l plus numbers of r equals target, then we have to return directly l plus 1 comma r plus 1. You already know why we are doing plus 1, one based indexing. Else if the sum, okay, okay, I can just write this simply. Int sum is equal to this part. If sum, yeah, that's simpler. So if sum equally is greater than target, then what you have to do is then we have to move L. Okay, if the sum is greater, then you have to move R. Sorry, we have to move R minus minus. Else we have to do L plus plus. Okay, so this should do it, and in the end we have to return this fallback. So let's run this. So it's accepted. Let's submit this. So yeah, we have solved this using of and time complexity. Okay, so this was all for the video. Thank you for watching.